Okay, let's go over number 4 here. So we have a spring stretched to a length of 8 meters. All right, so it's going to be, look, and it's, we know that the speed of the waves on there is 5 meters per second. And it says we are looking at the simplest standing wave that can form on that spring. Now, yesterday when I had the spring up front here, the simplest wave that could form on that spring looked like this. And this distance is 8.0 meters. How many wavelengths are there? Half a wavelength. So the actual wavelength here is 16. Right? If that length is half a wavelength and it's 8, a full wavelength would be 16. Okay, so the full wavelength of this wave is 16 meters. Now I can find what frequency is producing that waveform. So F will be V over lambda. Okay, so that'll be 5.00 divided by 16, which should give me 0.3125, but the 3 significant figures is 0.313 hertz. Okay, everybody follow what I did there?
What I did was, I did 8 divided by, 0.5 divided by 8.
Yeah, 0.5 divided, well, or 8 divided by 0.5.
Yeah.
Yeah, that gives you 16.
And then
Yeah, so same, you did the same thing, just thought about it differently. Okay, that's fine. All right, so now I've got the frequency that produces that. Now, yesterday, when I was doing the spring up front here, when I got the next waveform, how much faster did I have to shake the spring? Twice as fast. Okay? Remember, F1, F2, F3, those numbers that go on the F are the factors of the first or fundamental frequency. This is the fundamental frequency for the spring. F2 is 2 times that. F3 is 3 times that, and so on and so on. Okay? So the next frequency I would hear is twice that value. Everybody follow me on that? Now, in the workbook, there are a bunch of air column questions that I want you working on, okay? Because I guarantee you, there's an air column question on your unit exam, and there's an air column question on your final exam. Okay, I know that because they're both done. Okay, so we need to make sure we understand how air columns work. So I'll quickly review, okay, air columns here before we get started on them. If I have an air column that is closed at one end, okay, then I'm dealing with a closed air column. Right? The first or fundamental frequency that gets produced has a waveform like this. Okay? There's an antinode at the open end, and obviously a node at the closed end because that's where it's reflecting off. Okay? How many wavelengths are in that tube? 1/4. Okay? And that's where the formula lambda equals 4L comes from. Okay, for a closed air column at its fundamental frequency, 4 times the length of the tube will give me the wave, because there's 1/4 of a wavelength in the tube. Okay, everybody all right with that? Now, the next standing wave pattern that gets formed in that tube is F2, and it looks like this. What do I hear? Nothing. Okay? The tube does not resonate at that frequency because there's an antinode at the top. Okay? At F3, okay, I'll have this waveform in the tube. Okay? Do I hear a sound there? How many wavelengths are in the tube there? 3/4. Okay? Remember, at F1 I have 1/4. At F2 I have 2/4. At F3 I have 3/4, and so on and so on. I go up by 1/4 of a wavelength every time, and nodes and antinodes are separated by 1/4 wavelength. Okay? So in a closed air column, only odd numbered frequencies, or every other frequency, will actually produce a sound. Okay? So that's what we have to remember about the closed air columns. Open air columns work differently because they're open at both ends. They always have a node, or sorry, an antinode at either end. So their waveforms look like that. Okay, how many wavelengths are in the tube there? Half. Okay? There's half a wavelength in the tube here. Okay? That's why lambda equals 2L at the fundamental frequency for an open air column. Okay, and remember, that formula and the one for the closed air column are on your formula sheet, but they're not labeled open air column and closed air column. You have to remember which one applies. Okay, now this produces a sound. At F2, I have that waveform in the tube. How many wavelengths are in the tube there? One. Okay, remember, nodes and antinodes are a quarter of a wavelength apart. That's why closed air columns only resonate at every other frequency. Open air columns resonate at every frequency because they're a half a wavelength different each time. And antinodes are always separated by a half a wavelength. Okay, so in this one we have a full wavelength in there and we get a sound because there's an antinode at each end. Okay, and then the next one, okay, we'll have this waveform. Okay, so there's a full wavelength there, a quarter and a quarter is 1.5 wavelengths. Every other, okay, every next frequency is another half a wavelength larger, always making sure that there's an antinode, okay, present at each end of the tube. Okay, so on and so on. Now, ringing the bell from yesterday. Okay, so what air column questions are going to ask, okay, they might ask you to calculate the speed of sound, okay, giving you the information to find the wavelength and giving you the frequency. Or they'll give you the speed of sound, the length of the tube, and ask you to find the frequency. Or they'll give you the speed and the frequency and ask you to find the length of the tube. Okay? Those are the only three things that an air column question can ask. Okay? Find the length of the tube. You find that by getting wavelength. Okay? Find frequency, which means you find the wavelength and the length of the tube and the speed. Okay? Or find the speed. Again, use the length of the tube to get wavelength, frequency, find speed.
When you hear sound,
Yes. Open air columns resonate at every harmonic. Okay, first harmonic, second harmonic, third harmonic. Okay, closed air columns only resonate at odd harmonics. Fundamental 3, 5, 7.
so there's never a node at the end.
There's never a node at the ends for an open air column because they don't have an end. Right? They don't have a reflective point. Okay, so here's your standing waves questions. They're on page 5 and 6 in the workbook. So if you want to have that on your phone instead of here on the board, you can do that. Okay. Once you're working on those, and we'll go through some at random. Okay. The first bunch are all closed air columns, like the first 7 or something like that, 7 or 8. Yeah, the first 7 are closed air columns, and then 8 through 13 are some open ones, and there's one closed one in there. So. Okay, you can get to work on those, and I'll go through any that give us trouble. Okay, that's what we're working on today. On Monday, I'm going to go over Doppler effect. Tuesday, we do unit exam review. Okay, and then Wednesday is your unit exam. All right, that's the way it's going to work here for the rest of the semester. I posted your unit exam review package about an hour ago in Google Classroom. So your Unit 4 exam prep package is on Google Classroom. You can look at it this weekend. Okay, so let's have a look at number 10 here. So we have an open air column. So we know right away we're dealing with this situation, lambda equals 2L. Okay, its fundamental frequency is 384 hertz. Okay, what's the frequency of the next greatest harmonic to which this column will resonate? All right, if this is F1, what's the next one that'll resonate? F2. How many times bigger is F2 than F1? 2 times, right? Right? F2 is 2 times greater. Remember, just think back to the spring here at the front. When I wanted to get a pattern that had 2 antinodes, I shook it twice as fast. If I want to get the next humming sound out of this tube, I have to get twice that frequency. That's why it's 768 hertz, 2 times 384. So a lot of times when we have one like that, because there was also one like this for the closed air columns, people overthink it, which is exactly what I want them to do, okay? Just to realize, oh, right, this is just asking if I remember the simple relationship between the harmonic frequencies, okay? Any other ones giving us trouble? Okay, keep going then.
Because you did 4
it's open.
you only use 2. No, you did use 2 instead of 4. You just did an extra step for yourself. Times it by 3.
This is every odd number.
Yeah.
And then the closed one is every number. I mean, the open one is every How does about 3 minutes? Because it starts at 1, so it goes odd. So, and then if it's closed, and then it doesn't resonate, and then it goes on again. You know what I'm saying? So, what is it? So, you just multiply it on the next phrase. Oh, which will see just multiply by 3. So you're basically doing 1, 3,